So what we're going to talk about today is a special type of angle pair. They're called linear pair angles. Before we can dive into what linear pair angles are, okay, we have to talk about some important vocab. Right? And some of these vocab words you've probably heard of before. One is supplementary angles. Supplementary angles are angles that have a sum. What does sum mean to you in math? Yeah. Sum means to add. So two angles that add up to what? They're supplementary. Anyone heard that before?
180.
180. Yeah, they add to 180 degrees. It means they are supplementary. Complementary angles, again, are angles with a sum of what? 90 degrees. So supplementary adds to 180. Complementary means they add to 90. Adjacent angles. When you hear the word adjacent, what does that mean? Or no? Okay. Down across, close. Close. Not diagonal. Right next to each other. That's what it means adjacent. Okay? They're adjacent to. They're next to each other. So adjacent angles are literally that. They are angles that are next to each other. In other words, they share a side. Okay? Angles that share a side and a common vertex but do not overlap. In other words, they're just angles that are next to each other. In this diagram right here, this angle, ADB, is sharing a side with this angle, CDB. They have the same vertex. Okay? They're right next to each other. They're sharing that side that's in the middle. That's all I think. Two angles that share a side in the middle. And if you notice, they make a very big angle, ADC. Those are adjacent angles. Okay? One other really important thing to understand in order to understand the linear pair angles is this thing called the angle addition postulate. Okay? And a postulate, all that is in geometry, you're going to hear it a lot. It's just something that doesn't need to be proven as true. It's just like kind of a known fact or something that's really obvious that you just look at. Like if I had 2 apples and someone gave me 2 more, then I had 4. Because all you have to do is look at it and be like, yeah, there's 4 apples. Okay? Which is something that you don't have to do a lot of arguing or proving to accept as true. You can just look at it and be like, yeah, that makes sense. Okay? That's what a postulate is. And here's like the formal fancy phrasing of this postulate. We'll get into kind of like unfancy and formal meaning. When it says if a point lies on the interior of the angle, interior means the inside. So if a point lies on the inside of an angle, that angle is the sum of the 2 smaller angles with a shared side going through that given point. In other words, you have 2 adjacent angles, okay? And the measurement of the 2 adjacent angles, this and this, is equal to the big angle. So if you take this little angle, add it to 40, and add it to 83, the other adjacent angle, it's going to equal 123, which is the measure of that higher angle. Okay? What does that mean? So you have 2 little angles making a big angle. You just add those measurements together, and it will give you the measurement of the big angle. Okay? So we could say it in this diagram that this angle right here, QRT, plus this adjacent angle, SRT, is equal to the measurement of the entire angle, QRS. Okay, because that's what they make up. They made up that interval. Okay. That's what all the angle addition postulate is. Okay, so we're going to get some practice with that. We're going to get some practice with writing equations that look like this. That'll help us with what we're doing later on. Okay? So here we're going to use these diagrams to write an equation that represents the measure of the given angle. Okay? Well, my given angle here is ADC. So to write an equation that represents that angle, all I'm going to do is just add the 2 adjacent angles together. So I'm going to say the measure of angle ADB the measure of its adjacent angle, this guy right here, CDB, and it's going to equal the measurement of the entire angle, which is ABC. That's all that angle is in postulate. Little angle plus little angle equals the big angle. That's all that's saying. Okay. So how can we write an equation to represent the measure of that other big angle? Plus
Angle ABC
good.
plus ABC equals
Good. So this angle ABZ, so the measure of angle ABZ, plus measure the other little angle CBZ will equal the entire big angle, which is ABC. And that's true every single time. Add the little angles together equals the big angle. What's a little bit different? What's a little bit different about this one? Right? Yeah, there's three angles that are all kind of aligned with each other, right? One's adjacent to 2, 2's adjacent to 3, and they all make that big angle. Okay, but the process is still the same. But instead of just adding 2 angles, how many angles are we going to add? 3, right? And it's really nice. What do each of those angles have? Now the same vertex, what do you notice inside the little angles? Each have a what? A number. So can we use that method to name these angles? Yes. Am I okay to erase this? Everyone has this down? Sounds good. So instead of writing out all 3 letters, we can just say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to the measure of the whole entire thing. Measure of angle P2S. This plus this plus this equals plus this. Okay. Questions over that? Okay. Let's apply this to a problem. So in the diagram below, the measure of angle ADB equals 100 degrees. Find the value of x. You don't have to do this every time, but just for the purpose of what we're doing on the back. And you might do it every time to help you out. But let's write those equations just like we did in example 1. Okay? Because in the past, we would see a diagram like this, like last unit. And what would we be tempted to do to solve this? Set them equal to each other. But is it saying that anything's being bisected? No. So we can't do that. Unless there's something in the directions or marking on this diagram saying that something's being bisected, whether these angles are equal, you cannot set them equal to each other. Because they're not. Okay? We know another thing that we put in our toolbox, that angle addition postulate. Okay? If we know we have 2 adjacent angles, we can say that this angle, the measure of angle ABC, plus this angle, the measure of DBC, is equal to the whole entire angle. The measure of angle ABC. That's what we can use. So if it's not talking about bisecting, you might have to do the angle addition postulate. Okay? Well, what is ABC? What's written there to represent it? 4x plus 2. So we can say 4x plus 2 plus what's written there to represent DBC? 3x minus 7 is equal to, what did they say ABD was? 100. Right? Now we just have a normal equation to figure out what that is. But you don't have to write that first equation. I just wanted to show you where these numbers came from. So if you're getting a problem like this and it's saying the big angle is a certain degree, they gave you these little formulas for the little angles, just think, oh, this angle plus this angle equals the whole thing. Right? And then solve. When solving, and you get your cards out. Maddie, what's our first step when solving? Combine our like terms. So add the 4x and the 3x to get 7x. And combine the 2 and negative 7 with 2 minus 7. Or 5. And then we have to get x by itself. Brooklyn, what's our first step getting x by itself? Okay. Okay, 7x is equal to 105. And then what's our last step? Brandon, what are we going to do next? Good. Divide by 7. Throw some orange in there. Divide by 7. So then x ends up equaling what? 15. Are we done with this problem? Yep. Just set define x, we found it, we're done. That's the angle addition part. Add the two little angles together equals the degree. Well, this, having an understanding of angle addition postulate, will help us understand linear pair angles, the whole thing we're trying to learn today. Okay? Linear pair angles are just a pair of adjacent angles. Two angles that are next to each other. So what's special about them is that they're non-adjacent sides forming straight angles. Okay? That's what's special about them. They're still adjacent, just like we did on the front, except the bottom part forms a straight line. So look at this diagram here. Angle 1 is right next to angle 2. They're adjacent. They share that middle side. But if you notice, the arrows that aren't adjacent are forming a straight angle. This is also a straight line. Okay, I like to think of it here. It's as if we took one of these angles. Okay, here's the side that they share. If we just drop that down, this part just dropped down, we get a straight line. So it's no different. They're adjacent. Just what's special about linear pair angles is they're always creating a straight angle. Okay, every time. Right? And we talk about straight angles are also what? A line. It's also a line. So what does linear sound like? Linear sounds like line, right? So that's one way to think of it. Linear pair sounds like line. They're creating lines. Okay? And this leads us to this theorem. And the theorem is just a result that has to be proven true. So we talk about on the front, the postulate, there's no proof needed. You could just state it, yeah, that's true, by just looking. Just thinking about it for a second. Yeah, that's true. Okay? Theorems had to do some work. Someone had to sit down, do some math, and be like, see, this is why this works every single time. Because of the math that I did. Okay? That's the theorem. So the linear pair theorem says that if two angles form a linear pair, so if they look like this, if they create a straight line, they are automatically supplementary. And what does supplementary mean? They add to what? 180. Okay? So if you have a linear pair angle, they're always going to add to 180 every single time. So look at this diagram. Angle 1 and angle 2 form a linear pair. They're forming a straight line. So whatever angle 1 is, plus whatever angle 2 is always going to equal 180. Well, why is this trick? Okay, someone had to sit down and show you why, they had to prove why, because it's a theorem. Okay? Can't be accepted as true until someone proves it. Okay? Well, we can use that angle addition postulate to have an understanding of why this is true, of why this works. Okay? So because of this postulate, we know that the measure of angle 1, this angle right here, plus the measure of angle 2, that angle right here, creates, what big angle do they create? ABC. We create this bottom angle. Again, it's like if you take the slanted ones and fold them down and create a straight line. That is the big angle they create. So we can say that they're equal to the measure of angle ABC. You take those two angles and add them together, they create the big angle, which is ABC. Right? What do we know about ABC? We just said it. ABC is a, yeah.
So if it was like on a test, if you wrote like 9 ABC, would that be wrong?
Okay, because we're talking about angles. Because we're talking about an angle. So angles, can you add angles and equal a line? No. Angles and lines are not the same. So you have to keep it an angle. Okay, that's important. Can't write it is, yes, it is a line, but you can't add angles to equal a line. So you have to write it as an angle. We also know that ABC is a what kind of angle? It's a straight angle. We just talked about this. It's a straight angle. It's a straight line, which makes it a straight angle. And what do straight angles always equal? 180. Well, just like we did on the front, you don't have to flip back to it. I'll flip back to it. Okay, we had this equation here, similar to what we just wrote. We had two angles added together, and it equaled the big angle. Okay, and we knew that the big angle was 100 degrees. What did we do with that 100? To help us solve, we plugged it in. We took 100 and plugged it in for the big angle. Can't we do the same thing here? If we know this angle is 180 degrees, can't we just take 180 and plug it in for it? Yeah. Okay. So we can just take 180 and plug it in for angle ABC to get angle 1 plus angle 2 equals 180. So now here's what we did on the front. Right? Angle addition postulate every single time, except what's special about linear pair angles is their big angles always a straight angle. So when you do angle addition postulate with linear pair angles, they're always going to add to 180 degrees every single time. Okay? No different when we did on the front. It's just that they're always going to equal 180. Okay? Questions over that? And example 1 says in the diagram below, find the value of x for each linear pair. Well, we know we have a linear pair. We have two adjacent angles. They're creating a straight line. So what are they going to add to? 180. So you do this angle, which is x, plus this angle, which is 25, and it equals 180. Sometimes you're told you have a linear pair. Sometimes you have to be able to look at the diagram and know that you have a linear pair. And Jay, what's our step in solving? Our only step? Good. Subtract 125 from both sides. And 180 minus 125 is? Good. There we go. Does anyone know a shortcut rather than writing an equation? What could you use done? Yeah, you could have right away. Whenever you know an angle measure and you're just trying to find the other angle, you could have just done right away 180 minus 125. Totally fine. Okay? Here's the thing with B. Can we use that method with B? No, because it has this little expression. So when you have an expression written as an angle, you have to write it out. Trent, how are we going to set up this problem to solve? Good. Plus what? Good. Again, we have a linear pair. We know they add to 180 every single time. Right? Well, when we solve, what's our first step? Celeste, what's our first step in solving? Good. We combine like terms. What do we get? Good. And then keep solving. What's our next step in solving, Chris? Good. Minus 120. To get 60. And then our final step Logan, what do we need to do?
Divide by 6.
Very good, divide by 2. And x is equal to. Questions over this? Okay, whenever you're given a linear pair, whether by looking at the diagram or told you have a linear pair, the angles always add to 180. If this part confused you, don't worry about it right now. Just know I have a linear pair. I'm going to add them to 180. If you get that down, you're good for right now. In example 2, it says angle KPL and angle JPL are a linear pair. Okay? Sine x and the measure of KPL. Well, if we know we have a linear pair, Colton, what do we know about these angles? What do they add to? 180. Very good. So if we know they add to 180, that's how we can set it up. We can just say 2x plus 24 plus 4x plus 36 equals 180. And then we solve. You have to be super careful. I see this a lot. You just learned about segment bisectors. Okay? And it kind of looks like this guy right here is bisecting that segment. It looks like it, right? So sometimes I see we've given this similar problem, and students just say, oh, it's a segment bisector. I'm going to set those equal and solve. Okay? Because it looks like it's written on the segments, right? But what is a good indicator that you're not dealing with segments, but you're dealing with angles?
The directions, or just like it says mostly angles.
Well, yeah, the directions say angles, good. Sometimes we don't read directions, we just look at diagrams. Happens. Okay. What in the diagram indicates to you that you're dealing with angles? Yeah, we have little degree symbols here. So whenever you see degree symbols, you are not dealing with segments. Okay, you're dealing with angles. So if you look at the diagram without reading directions, directions clearly tell you you're dealing with angles. But sometimes we don't look at read directions. We have angle symbols there. We're dealing with angles. And when we look, these angles are not the same. This is a big angle, that's a small angle. The kind of indicator that you're not going to be setting equal to. You're going to add them to 180. Okay? When we solve, actually, what's our first step? Yeah, combine like terms. When we combine like terms, actually, what do we get? 6x plus 16. Perfect. And we gotta keep solving. Gabe, what's our next step when we solve? Good. And then, Alyssa, what's our last step in solving? Good. And then when we divide by 6, x ends up equaling what? Alright. We done? Why not? Why can't we just start working on practice? Yeah, we have to find angle KPL. You cannot move on until you find that angle. Here's angle KPL. What do we have to do with 20 to find angle KPL? Plug it in. So 20, plug it in for x, equals 2 times 20 plus 24. And when we do so, 2 times 20 plus 24 is 64. Questions over that? And linear pair angles is just using that angle addition postulate, except we always create straight angles. So we're always going to add a 180 degrees. Okay? You can use the angle addition postulate, you might not necessarily have a straight angle, but you won't be setting it equal to 180. Over this? Okay. The rest of the time is yours. You have time to work on this practice.